Hello everyone, welcome to the Luminous Science. In our previous two videos, we had seen about the molecular spectroscopy and vibrational spectra, which is also called as infrared spectroscopy. Now let us see some problems on molecular spectroscopy and infrared spectroscopy. So the first question is, the moment of inertia of HCl is 2.71 into 10 to the power of minus 14 gram centimeter square. Calculate the bond length. So here they have given the moment of inertia, that is 2.71 into 10 to the power of minus 14 gram cm cube, and also we should note the mass of hydrogen and chlorine. So we'll consider mass of H as M1, which is 1.008 grams, and M2 of Cl, which is 35.451 gram. And to calculate the moment of inertia, we know the formula mu r square, which is equal to, as we know, mu is the reduced mass, which is m1 into m2 whole divided by m1 plus m2 r square. So we need to calculate the r square, and we know the value of m1 and m2. That is, m1 and m2 are the atomic masses which are represented in grams, and dividing them by the Avogadro number Na, which is nothing but Avogadro number, its value is 6.023 into 10 to the power of 23. And why we are dividing them by the Avogadro number is because we need to calculate for one single molecule of HCl. So we need to know the value or the mass of one atom. So hence we need to divide them by the Avogadro number. And since here we know the formula is m1 m2 whole divided by m1 plus m2. So if we divide this, then if we divide this, we get this format, this m1 m2 whole divided by Na, which is whole divided by m1 plus m2 by Na. So now if we take reciprocal of this, we'll get the division will be converted into multiplication. This is why we have written here mu is equal to 1.008 into 35.451 whole divided by 6.023 into 10 to the power of 23 multiplied by 6.023 into 10 to the power of 23 whole divided by 1.008 plus 35.457. And thus we'll get the mu value, which is equal to 35.740 whole divided by 36.465. On dividing this, we'll get the reduced mass value as 0.9801 gram. Now substituting this value in the equation which we know, that is I is equal to mu r square. Since we need to find the value of r square, we'll move this mu to the denominator, which will give us r square is equal to 1 by mu. And since we need only value of r, we'll take square root of 1 by mu. And thus substituting the values, that is r is equal to square root of 2.71 into 10 to the power of minus 14 whole divided by 0.9801. We'll get the value as 1.633 into 10 to the power of minus 12 meters. So this is the bond length. So here they had given us moment of inertia, and also we know their masses. By substituting these masses and moment of inertia in the equation that we know, which is I is equal to mu r square, we'll get the bond length. Now we'll see the second question. A pure rotational spectrum of a gaseous HCl consists of a sense of equally spaced lines separated by 20.50 centimeter inverse. Calculate the internuclear distance of a molecule, and the atomic masses are H is equal to 1.673 into 10 to the power of minus 27 kg, and Cl is equal to 58.06 into 10 to the power of minus 27 kg. And here they have given the masses of H and Cl, which is 1.673 into 10 to the power of minus 27 kg, and mass of Cl. Mass of Cl is 58.06 into 10 to the power of minus 27 kg. And here they have mentioned that the sense of equally spaced lines, the spectral lines are equally spaced, which is nothing but 2b. 2b is equal to 20.50 centimeter inverse, but we need only the value of b, which is the rotational constant, and b is equal to 20.50 divided by 2, from which we get the value 10.40 centimeter inverse. and we know the equation to calculate the rotational constant, that is B is equal to h by 8 pi square IC centimeter inverse. Since we need the value of I, that is moment of inertia, we'll just reverse this equation. Then we'll get h by 8 pi square BC, and here we know h represents the Planck's constant and c is the speed of light. And substituting these values in I to this corresponding equation, we'll get I is equal to 6.625 into 10 to the power of minus 34, which is the value of Planck's constant, whole divided by 8 into 3.14 square, which is the value of pi, and into B value we know that 10.40, and into speed of light, which is 3 into 10 to the power of 8. When we simplify this, we'll get the moment of inertia as 0.2689 into 10 to the power of minus 56 kg centimeter inverse. Sorry, we'll get kg meter square. And now we need to calculate the mu, that is the reduced mass. And for that, we know the equation, which is m1 m2 whole divided by m1 plus m2, and since they have already given the masses of H and Cl, we'll just simplify them here. That is 1.673 into 10 to the power of minus 27 into 58.06 into 10 to the power of minus 27 whole divided by 1.673 plus 5 58.06 into 10 to the power of 27. And when we simplify this equation, we'll get the value of reduced mass, that is 1.626 into 10 to the power of minus 27 kg. And since we need to calculate the bond length, we know another equation, that is I is equal to mu r square. Since we need only the value of r, then r is equal to square root of I by mu. Substituting the value of I and mu from the previous obtained value, that is 2.689 into 10 to the power of minus 57 whole divided by 1.626 into 10 to the power of minus 27 respectively, then we'll get the bond length as 1.29 picometer. Picometer is nothing but 1.29 into 10 to the power of minus 12 meters. Now, let's see the third question. The fundamental vibrational frequency of HCl is 2890 centimeter inverse. Calculate the force constant of this molecule, and the given atomic masses are, for H it is 1.673 into 10 to the power of minus 27 kg, and for chlorine it is 58.06 into 10 to the power of minus 27 kg. First we'll write the given values, that is m1 of H, which is equal to 1.673 into 10 to the power of minus 27 kg. m2, which is of chlorine, equal to 58.06 into 10 to the power of minus 27 kg. And here they have mentioned the fundamental vibrational frequency, which is represented by omega oscillation, which is equal to 2890 centimeter inverse. So first we need to calculate the value of reduced mass, that is mu. And so m1 m2 whole divided by m1 plus m2, and substituting the corresponding values in this equation, that is 1.673 into 10 to the power of minus 27 into 58.06 into 10 to the power of minus 27 whole divided by 1.673 plus 58.06 into 10 to the power of 27. Substituting this value and on evaluating, we get the mass of value for reduced mass, that is 1.626 into 10 to the power of 27 kg. And we know the formula for force constant, which is K is equal to 4 pi square C square omega square oscillation into mu. And substituting the corresponding values of pi, C, omega and mu to the equation, we get K is equal to 4 into 3.14 whole square into 3 into 10 to the power of 8 whole square into 2890 square into 1.626 into 10 to the power of minus 27. And then evaluating these value, we'll get the value for the force constant K, which is 483 into 10 to the power of 2 Newton per meter. Since the unit for force constant is Newton per meter, we are representing it in Newton per meters only. We'll see our fourth question. The force constant of carbon monoxide is 1840 Newton per meter. Calculate the vibrational frequency in centimeter inverse. And the spacing between the vibrational energy level is in electron volt. The atomic masses of our carbon is 19.9 into 10 to the power of minus 27 kg, and of oxygen is 26.6 into 10 to the power of minus 27 kg, and the value of 1 electron volt is equal to 8066 centimeter inverse. First we'll write the given, that is force constant K is equal to 1840 Newton per meter. M1, that is of carbon, is 19.9 into 10 to the power of minus 27 kg, and M2, which is of oxygen, is 26.6 into 10 to the power of minus 27 kg, and 1 electron volt is equal to 8066 centimeter inverse. And one more important thing, it is very necessary and also need to write the given while you are writing the answer for the question provided, because in some of the examination, like in semester examinations, board examination, the given value will also contain marks. So though you don't know any kind of formulas, or if you are unable to decode this problem, if you just write the given, then also you will get half or 1 mark. So it's always better to write the given from the question in your answers. Now we'll calculate the mu, that is reduced mass, given by the formula m1 m2 whole divided by m1 plus m2. Substituting this corresponding values, that is 19.9 into 10 to the power of minus 27 into 26.6 into 10 to the power of minus 27 whole divided by 19.9 plus 26.6 into 10 to the power of minus 27. When we evaluate this, calculate this, we'll get the reduced mass as 11.4 into 10 to the power of minus 27 kg. And we know the equation for the vibrational frequency, that is omega bar oscillation, which is given by 1 by 2 pi c square root of k by mu. Substituting the corresponding values, that is omega dash oscillation is equal to 1 by 2 into 3.14 into 3 into 10 to the power of 8 into square root of 1840 whole divided by 11.4 into 10 to the power of minus 27. We'll get the value of omega oscillation as 2140 centimeter inverse. And they have also given the spacing between the two energy level, which is nothing but delta E is equal to E V plus 1 minus V EV, and this can simply be written as delta E is equal to E2 minus E1, where this represents the energy level, and delta E, which is equal to H omega, which is represented in joules, but here they are representing in centimeter inverse, and also the spacing between the energy levels are represented in terms of electron volts. So first we'll see how to represent or convert this joule into centimeter inverse. To convert into centimeter inverse, we have the formula delta E, which is equal to H omega Hc, which is equal to omega by C, which is nothing but omega dash, which we have got here, that is 2140 centimeter inverse. And since they have given 1 electron volt is equal to 8066 centimeter inverse, and simply dividing for the value of delta E, omega dash by 1 electron volt, that is 2140 whole divided by 8066, we'll get 0.625 electron volt. Thereby the vibrational frequency and the spacing between vibrational frequency is 2140 centimeter inverse, and spacing between the vibrational energy level, which must be represented in electron volt, is 0.265 electron volt. Now let's see question number 5, that is the reduced mass of HBr is 1.64 into 10 to the power of minus 27 kg. Here they have already mentioned the reduced mass, that is mu, and the force constant, that is K, is equal to 407.9 Newton per meter. And we need to find out two values, that is the vibrational frequency, which is omega, and 0 point energy and fundamental frequency of the HBr. The 0 point energy which we need to calculate, and the fundamental frequency of HBr, which is omega naught. And we know what is 0 point energy. Though the electron in the 0th energy level, their energy will not be 0. but will be more than 0. It might be 1 by 2 or 1, but the energy of any atom or a molecule cannot be 0 because they will be under a continuous vibrational energy. So now first we'll write the given content, that is mu, a reduced mass, which is 1.64 into 10 to the power of minus 27 kg, and K, which is force constant, 407.9 Newton per meter. And we know the equation to calculate the force constant K, which is nothing but 4 pi square c square omega square mu. And by rearranging this equation, we'll get omega square is equal to K by 4 pi square c square mu. Substituting the corresponding values of this equation, we'll get 407.9 whole divided by 4 into 3.14 whole square into 3 into 10 to the power of 8 whole square into 1.64 into 10 to the power of minus 27. We'll get the corresponding value for omega square, which is 7.007 into 10 to the power of 10 meter raised to the power minus 2. And here it is given on square. So we need only the value of omega. Thereby taking the square root of this value, we'll get 2.647 into 10 to the power of 5 meter inverse. And we also need to calculate the fundamental frequency, which is given by the formula omega naught is equal to omega dash into C, which is nothing but omega dash is 2.647 into 10 to the power of 5 into the speed of light c, which is 3 into 10 to the power of 8, which gives us the value of 7.94 into 10 to the power of 13 per second. And to calculate the 0 point energy, we know that we have a formula of 1 by 2 h omega naught. 1 by 2 into h is nothing but Planck's constant, which is given by 6.625 into 10 to the power of minus 34 into 7.94 into 10 to the power of 13. And by calculating this value, we'll get 0 point energy in terms of joules, that is 26.31 into 10 to the power of minus 21 joules. Hope this video of solving the problems related to molecular spectroscopy and infrared spectroscopy was useful to you. If you have liked this video, kindly do like, share and subscribe. Thank you all for watching. See you all in my next video.